Hi everyone, this is Anushka and welcome back to my channel A in Economist. So from today we'll be starting off a very crucial chapter in your advanced econometrics, which is specification error or known as specification bias, right? We'll start off this chapter. This chapter is especially very helpful if you are doing empirical research. Those people who are pursuing PhD in empirical research, specifically for you guys, this chapter will be very important. Other than that, people who are pursuing your undergraduate or postgraduate courses or any econometric enthusiast will find this chapter very helpful. But again, as I'm saying, for PhD people, those people who are pursuing advanced studies in econometrics, you will find this chapter extra helpful because this is the base of any kind of empirical research, right? So let us straight away see what is specification error. This is going to be an introductory session on specification error. I will introduce this topic and I'll also, mention what are the types of specification error in this video. And in the next video, we'll be, seeing the consequences. If those specifications error are present in your model, what will be the consequences for that? That we will discuss in the next successive videos, right? So this is the agenda. Now let's go about with the specification error. See, to develop an empirical model, empirical means based on the data, based on the sample data, right? Whenever you are trying to form an empirical model, suppose you have some research question, you want to see that whether experience matters in determining the wage or not, right? To, determine the wage, weekly wage or monthly wage of an worker, you want to test that whether experience matters or not. Then what will you do? You will collect some data, you will form a model, you will form an empirical model to test this specific research question, right? So before going into research, you always need to form an empirical model. Without forming a suitable model or without selecting, this we call as the model selection. Without selecting an appropriate model, you cannot carry on your empirical research or any sort of research, so as to say, right? To develop an empirical model, there may be 5 different types of specification error. Now, since we are human beings, we make mistakes, right? Whether it can be due to our carelessness, or it can be due to lack of data, or it can be for any reason. If you deviate from your true model, right? There is a true model and there is a model that you are using mistakenly, right? Now, if there is any deviation between the true model and the model that you are using for your research purposes, then you will land up having the specification error. Any sort of deviation from the original model will give you specification error, and there are different types, there are different possibilities for that. In how many different ways you can commit this error, I have listed down for you. There are 5 different types of specification error which are mostly prevalent in your empirical model. The first of them is omission of relevant variable or variable. Suppose in your model you have 2 to 3 important variables, but mistakenly what you have done, you have omitted a relevant variable. Relevant means statistically significant. Relevant variable means statistically significant variable. It can be due to lack of data, or it can be due to your, uh, misjudgment or something. You have eliminated, due to some reason, you have eliminated or you have omitted one relevant variable in your study. In that case, one specification error will arise, that is known as the omission of relevant variable. Specification error due to omission of relevant variable. This is the first type of mistake that you can commit. Now, the second type of mistake is just the opposite, inclusion of unnecessary variables. Suppose you need only 2 variables to determine the wage of the worker, but still you have added an unnecessary third variable into your model. In that case, also the model will not be a good model because the true model is not established. You have mistakenly selected a wrong model. So this is the specification error that will arise due to inclusion of an unnecessary variable in your model that may arise. Now the third point, the third type of specification error will be due to wrong functional form. Suppose your original model is in the additive form, but while selecting the model for your research, you have taken a multiplicative form, right? Instead of taking additional form, additive form, you have taken a multiplicative form in your model. So in that case, or you have taken a log linear form in your model, anything which is deviating from your true form of the model will give you specification error, and this kind of specification error is due to the wrong functional form. Now, the fourth type of specification error is known as the error of measurement. Error of measurement means what? Suppose the exact data of a variable is not known to you, right? Exact variable, suppose experience is a variable, the data for which is not exactly known to you due to some reason, due to lack of record or something, due to some issue, the experience data is not available to you. Now, what you will do, you will define a proxy of that, right? You will try to estimate that variable taking a close proxy or a close substitute of that variable that you will include in your particular model. So then also what will happen? Specification error will arise because again you have not taken the original variable which is experience in your model. Instead of that, you have taken a substitute variable which should have certain errors, right? Any variable, any proxy variable that you can take, it cannot exactly measure the experience. It can only give you an idea of the amount of experience the employee is having, right? So specification error, this type of specification error will arise due to error of measurement, due to lack of having proper data regarding the actual variable. You are using some proxy variables, right? This is the fourth point, and there is a fifth possibility, which is the incorrect specification of the stochastic error term. So this point is almost similar to the wrong functional form, but this is defined only on the stochastic error term, right? As we know, any kind of econometric model has a stochastic error term to capture the real life complexities. No model, no econometric model is absolutely, you know, deterministic, right? No model is absolutely deterministic. One-to-one relationship is usually not observed in real life scenarios because there are several variables who are affecting the outcome variable or the dependent variable. And to capture those complexities, right, to capture those real life complexities, you need to include some stochastic error term in your model. We have discussed this many times before. Now, if you do any kind of mistake in specifying this error term, right? If you do any kind of mistake, again, you can take that example that instead of additive nature, you have taken multiplicative nature or any other nature of your stochastic error term, then also your model will not be rightly specified. And this kind of specification error is known as specification error due to incorrect specification of stochastic error term, right? I hope this concept is absolutely fine, that there are these five kind of mistakes. There are five kind of mistakes that you can commit while selecting your model for your research purpose or for your project or thesis purpose, anything, right? So that is the thing. Now let us formally define this thing. Suppose we start with the omission of relevant variables. So how do you explain it mathematically or, taking original models? Suppose our true model looks like this. Suppose our true model, I'm taking a random model. You can take any model as you want. Suppose yi equals to beta 1 plus beta 2 x2i plus beta 3 x3i whole square plus beta 4 x4i whole cube plus ui for all I from 1 to n. Suppose this is your true model, right? So in your true model, how many variables you have? X2, x3, x4. Three explanatory variables are there in your true model. But you, instead of using this particular model, what you do, due to some mistake, due to some mistake, what you do, you consider the model as, you consider the model as this. Suppose you write yi equals to alpha, or write alpha 1 plus alpha 2 x2i plus alpha 3 x 3i square plus say vi for all I equals to 1 to. Suppose this is the scenario, right? This is your true model. This is the true model that you should use, right? You should use in your research or any purposes. But due to some mistake, due to some error, what you have done, you have omitted a relevant variable. Suppose x4 is that relevant variable, right? X4 is the omitted variable here. Suppose this beta 4 is not equals to 0. So basically, X4 is the statistically significant variable. That is a relevant variable means statistically significant. Suppose you have tested this that beta 4 is not equals to 0 in hypothesis testing, you have got this. So X4 is a statistically significant variable, but still you have omitted this variable from your study. See, this new model that you are using in which you don't have this X4 variable, then what we can say here is that clearly the error that you have here, this DI error must have some influence of this X4I, right? So this we can clearly see from our model, and this is what is known as omission of specification error due to omission of relevant variables. Now it has some severe consequences in this video. Since this is an introductory video, I will not discuss consequence here. From the next video onwards, we will take each of these cases and we will in detail see what will happen if omission of relevant variable is occurring in your model, what will be the consequences, how we can deal with this, everything will be done. I'll make separate video on each of these 5 types, right? So stay tuned for that. As of now, just understand the concept. So this is the first type of specification error which is done. Now see the second type, which is the inclusion of unnecessary variables. So what you will do, again, you will define a true model. Suppose the true model is just the same as this. We are not changing the true model. So let me again write the same model that we considered before. Beta 1 plus beta 2 x2I plus beta 3 x3I square plus beta 4 x4I square beta 4 x4I cube plus ui. So again, this is the original model, exactly the same model that we have considered before. But instead of using this true model, what you use, you consider the following model. You have considered this following model, yi equals to say gamma 1 plus gamma 2 x2I plus gamma 3 x3I square plus gamma 4 x4I cube plus gamma 5 x5I whole to the power 4 plus say u1I for all I from 1 to. Now what you see here is that this x5I is not present in the true model, but you have included this in your model selection. While selecting your model for your research purpose, you have added an unnecessary variable, right? See here, unnecessary variable. So suppose in hypothesis testing, you have found that this gamma 5 variable is not equals to 0, right? This gamma 5 variable is exactly equals to 0. You have tested the hypothesis and you have got that this gamma 5 is exactly 0, which basically means that x5, the variable x5 is statistically insignificant. Statistically insignificant means this variable x5 is not contributing in the variation of yi. In the previous case, the variable x4 was statistically relevant variable, significant variable, which basically means it has the power to affect the outcome variable yi. But here, in our particular case, in this particular case, what we see is that x5 is unnecessary variable, which basically means x5 does not have any explanatory power to explain the variation of our outcome variable yi. But still, if you include it by mistakes, we are talking about mistakes here. What kind of mistakes researchers can commit in the research work? That is what we are discussing. So mistakenly, they have included x5 as the explanatory variable in the model. In that case, what will happen? In that case, this u1i, what will be now this u1i? This u1i will be simply ui minus gamma 5 x5I whole to the power 4. Right? This is very clear from the discussion we had. So u1i now, this u1i will be ui minus gamma 5 x5I square. And this will give you, this is the new error term. This is basically the new error term. Right? If this is the scenario, then you will have specification error due to inclusion of unnecessary variable in your model. Again, I'm not going into consequences here. I'll make a separate video for that, right? So this is the second point, which is done. Now see the third point, which is the wrong functional form. So this wrong functional form, as I have told you, suppose your true model is simple. yi equals to beta 1 plus beta 2 x2i plus beta 3 x3i square plus beta 4 x4i cube plus ui. Suppose this is the functional form you have. But again, due to some mistake, what you do, you consider the functional form as this. The natural log of yi equals to this. The right hand side remains this. Suppose I call it mistake number 1. This is one type of mistake that you can commit, right? Everything else on the right hand side remains the same. Suppose I call it vi1, right? So for all I, you make this mistake that instead of taking yi, convert this model in the log linear form. This is the log linear form. So this is again a wrong functional form. Or you can do another mistake like this. Suppose you write 1 upon yi is the right hand side. Right hand side remains the same. Or you can make any mistake on the right hand side as well. Suppose this is yi, this is fine. But instead of say x2i, you write 1 upon x2i. Instead of x3i square, suppose you write root over of x3i and the rest of the things remains the same. Right? This is also a kind of mistake that you will commit, right? So you can make mistake either defining the dependent variable or while defining the explanatory variables in your model. Any such mistake will give you specification bias, specification error due to wrong functional form. Right? This is what is the third mistake that the researcher can commit. Now, fourth thing is the error of measurement. As I have told you, in error of measurement, we define proxy variables. So, for example, suppose consider the model. Let us consider the model. The model looks something like this. Star, yi star equals to beta 1 star plus beta 2 star x2i star plus beta 3 star x3i star whole square plus beta 4 star x4i star cube plus ui star. So the original model remains the same. The original model is as it is, which we have considered here. So see, the true model is not changing. We are not talking about the true model. Here, under error of measurement, what we have done, see, we have modified the model like this, where this yi star is basically yi plus ei, and the xi stars will be simply xi plus ei. For, let me change the error here. This is say wi. For all I and for all I, this is the scenario now. So what can you say about xi star and yi star now? What we can say is that xi star and yi stars are the proxies. They are the proxies for xi and yi respectively, right? So suppose we don't have the data about the original variables xi and yi. So what we do, we find out a proxy variable. We found out a proxy variable and we include that in our model and we work with this particular model. So here the outcome variable is also having an error of measurement, and this explanatory variables here, see, the explanatory variables are also the star represents the error of measurement. So star, here the ei and wi. See here, this ei is the error of measurement of yi and wi is the error of measurement of xi. So these are the errors of measurement. Errors of measurement of yi and xi respectively, right? So see here, if ei goes to 0, If EI goes to 0, can you say what will happen? What does this mean? If EI goes to 0, then yi star will go to yi, right? If this error of measurement, so see EI and WI, we call this EI and WI as the errors of measurement. Now, if this error of measurement of EI goes to 0, then what will happen? Yi star will tend to yi, which basically means yi is tending to the best substitute. Yi star will become the best substitute of yi. And when it is exactly 0, it is exactly the same. If I remove this tending sign and I make it exactly equal, suppose I make it exactly equals to 0, so yi star will be exactly equals to yi. This is very evident from this particular relationship. See here, if ei is 0, then yi star equals to yi, which basically means yi star is the best substitute of yi. There is no sort of error, right? There is no sort of error of measurement, and yi star, even if you take the proxy of yi, this is the best possible proxy that you can take, and the results will be unchanged. If this error of measurement is 0, but in case of error of measurement, if it is present, this variable will be usually not equals to 0. That is why the problems will arise, right? If they are the same, then it doesn't make any sense to study this error of measurement separately. Usually we'll see this error of measurement is not equals to 0, and in that case the proxies that you will find out for xi and yi, they will not be good proxies. They will not be sufficiently good proxies. That is why many problems will be created, that again we will discuss in some other video. And when wi goes to 0, same thing. Wi if goes to 0, xi star will be going towards xi. Again, xi will be tending towards the original xi, which means xi is becoming the best proxy if this wi, error of measurement of xi, tends to 0. So ei is basically error of measurement of yi, and wi is basically the error of measurement of xi. Right? I hope this is clear. And this xi star and yi star are the proxy variables. Whenever ei and wi will be tending to 0, xi star and yi star becomes the best proxies, is tending towards becoming the best proxies. And if they are absolutely equals to 0, then yes, xi star is exactly equals to xi, yi star is exactly equals to yi, and it becomes the best proxy, right? So this is what is the errors that will come. The errors that will come into picture when ei is not equals to 0 and wi is not equals to 0 will be the specification error due to error of measurement, right? Specification error due to error of measurement, right? So this is the fourth kind of error that you can commit. And the final thing is the incorrect specification of the stochastic error term. Again, we can take a very simple example. Suppose your original model, true model. Suppose the true model is this, yi equals to beta xi ui for all I from 1 to n. Suppose this is the original model. Now, what is the form of stochastic term here? What is the form? The error term is in the multiplicative form. Ui is in the multiplicative form, right? Error term is in the multiplicative form, that which you can see here. The explanatory variables and the error terms are in the multiplicative form. But again, due to some mistake, what you do? Due to some mistake, suppose you take your model as this. You select your model for your research as this. Suppose this is gamma xi plus, say, ui. Suppose you use this kind of a model. I is from 1 to n, right? Now, if you take this kind of a model, what is the form of the stochastic error term? Ui becomes in the additive form. Additive form. Ui comes into the picture in the additive form, which is not the true form of the model, right? This is not the true form. We are completely deviating. We are, changing the specification of the stochastic error term. The error term is coming in the multiplicative form in the original model, whereas if you commit any mistake, if you do not judge your research question properly, if you do not know which kind of model you should use in which kind of situations, then you can commit this mistake that you try to enter the stochastic error term in the additive form, which will give you misleading results, right? So these are the 5 kinds of mistakes or 5 kinds of specification error that as a researcher, as an econometrician or a statistician, you can commit while selecting the model. These are the problems of model selection when you are trying to enumerate empirical models, right? In the first line, I have told you these are the problems related to empirical modeling of data, statistical data or econometric data, whatever you call it. So these are the 5 kinds of mistake which I wanted to share with you. I hope you like this video. If you find this video helpful, please give me a like and do subscribe to this channel, AN Economist. And from the next video, we will go into each of these cases and we will, derive everything. What will happen if these specification errors are present? I'll make separate videos for each of them and we'll see what will be the consequences, and we'll also compare between the specification errors of all the 5 errors that we have done. We will do a comparative analysis that which one is more severe, which one is less severe, and so on and so forth, right? So these are the agenda for the next successive videos. Thank you so much for your time and let's meet you in some other video.